So let's talk a little bit about some specifics on how other societies like China, India, Islam contributed to the development of technology, knowledge that helped support what will become the scientific revolution in Europe. So we're going to take a brief look at the cultures associated with China, India, and Islam, or the Arabic-speaking peoples. Let's start with China. In your textbook on McClellan and Dorn, and again, I've not assigned this chapter to you because I think you've got plenty to do. However, if you're interested in some of these technologies we're going to talk about today and want to make that the focus of your research, that's fantastic. Go for it. Please use that index in McClellan and Dorn, take a look at some of those chapters and get going. So we've talked about how in how in Egypt and in Mesopotamia that we often see government support for technology and driving technology and its developments, especially those developments associated with agriculture, food production. And the same goes for sure in China. We get the first emperor of China in the 3rd century BC. And one of his aims, in addition to creating peace in China, China had been in the middle of a civil war for centuries, was to try to work on the agricultural output. And the Emperor Chen did indeed double the agricultural output of China. And he did this through great technological innovations. We talked about the Grand Canal, where he is reshaping the waterways of China through extraordinary amounts of labor. And he also added terraced agriculture. I don't have any images for you here, but terraced agriculture, where you actually sort of take an incline, a mountain, and start to shape it through artificial means, through digging, through excavating, right, to be able to make that land arable, to be able to plant that area. He also crafted lots of roads, as we said, the canals, some 1,100 miles of canals. And the Chinese emperor and his followers, his fellow emperors, were also interested in medicine and promoted the study of medicine. Now, most of them were trying to look for an elixir of eternal life, and so you might think of this not so much as medicine, but quackery. But still, we think of, back in the day, some achievements and some impetus by the emperors to engage in medicine, and a field of medicine today that is very well respected. So again, the origins of that are from state sponsorship in ancient China. Gunpowder. You'll find, if you take a look at McClellan and Dorn, that in the 900s AD we get the first recipe for gunpowder in China. Now, we think this gunpowder was used primarily for fireworks, and it might have had religious purposes for celebrations, to drive demons away. We don't know for sure, but it seems to have been mostly for beautiful displays, fantastic displays. As you know, gunpowder over time goes from this fireworks application, and the Chinese are the first to actually use it for ballistics. We would call it ballistics, where we have projectiles that we want to force through tubes to attack our enemies, to render or incapacitate our enemies. So gunpowder, the first one of the great military technologies coming out of China, that will make its way to Europe some 500 years later, after it's discovered in China, but it will get there through those great communications and trade routes. Paper. The Chinese will be the first to develop paper as a writing medium, and that is fiber. As you probably know, paper is actually made from wood pulp and or other kinds of plant fibers, and the Chinese are the first to do this, to craft this. The Chinese will also give us porcelain, so that is a ceramic, which most of our civilizations have had, but porcelain will be lighter, finer, and require much more ability to control heat, to control the ingredients for porcelain, the various materials used to make a very fine kind of a product there. And then finally, the compass. It is the Chinese who first develop a compass that indicates true north, magnetic north, and the compass will be very important, as you well know, for travel, for discovery, for communication, for map making. So after that great list from China, uh, we want to move on to Islam. And again, if you're interested in Arabic culture, if you're interested in the world of Islam, McClellan and Dorn will give you lots of discussion about the various achievements, the various contributions that Islam offers us. We have other videos or presentations in this section on Islam, so feel free to delve further into this. Islam, one of those great conduits of culture that follows the Roman Empire and maintains an urban setting in Mesopotamia, in Arabia, in Spain, in North Africa. And at those urban settings, we will continue to have what the Muslims will call houses of wisdom, where scholars will copy documents of the past, but also try to interpret them for their own means. And so we will get the works of Aristotle preserved. We will get the works of the mathematicians of Alexandria preserved. A lot of discussion of astronomy preserved, medicine preserved. And so we will see great development there. Because, as you know, we've already said earlier in a video, the Muslims will travel extensively for trade purposes. They will also come in contact with knowledge, with wisdom of other cultures. And in particular, from India, we will gain this idea of the number 0. From India, we will get what eventually will come to be called Arabic numerals, which we use today. And when you put together Greek mathematics, when you put together the preservation of Greek mathematics that the Muslims are doing in particularly Babylon, Baghdad, which becomes Baghdad, when we see that we're pulling all of this together, that great mathematic tradition going all the way back to Mesopotamia, the sexagesimal system, add upon that the Greek tradition with Pythagoras. Now we've got Arabic numerals and the number 0. The Muslim scholars will come up with that most dreaded class for many students, algebra. Yes, algebra, an Arabic word for a mathematical system, right? So we are advancing mathematics here in the Middle Ages, here in Muslim countries, and this will be very important for the developments that Copernicus will have later, and certainly that Isaac Newton will have as he builds upon this mathematics to develop what will become the calculus. So from Islam, lots of great contributions. From India, there's again plenty to look at in India, and we're just going to concentrate on a few things here. But we think from India, just like with the Greeks, we get some early attempts at medicine and surgery. Again, in China, medicine very important. In Islam, very important as well. The Greeks, very important for medicine. And for India, we'll get lots of medical treatises, lots of herbals, trying to figure out how to treat medicines, but also an attempt at surgery and an attempt to record that information. In particular, the Indians worked a lot on battle wounds, so wound treatment, wound surgery, to try to make wounds not be so potentially catastrophic to an individual, so making lots of advances there. Astronomy also, much like all of our early civilizations, the Indians very much interested in the heavens and the earth and their relationship. And as we said before, from India we will get the concept of the number 0. Some suggest it has a lot to do with their philosophy, the idea that in Buddhism, in Hinduism, there is philosophically the concept of nothingness, right? That there is nothingness. And so this idea of 0 perhaps relies upon the philosophical idea that we can actually measure that which is nothing. Yeah? And then, as we said before, the kind of numeric calculation, and you saw this in your video on math, the number 1 that you get out of India. We think that the actual version of numbers which we use today coming out of India were adopted by Arabic traders, were adopted by Muslims, and becomes the mathematic notation that we now say are Arabic numerals. So what kind of conclusions can we make in these 2 videos on world trade, communication, etc.? Well, communication and trade routes facilitate connections between ancient and medieval societies around the world. These communication and trade routes help to preserve knowledge and share knowledge of technology, science throughout the globe. So technology and philosophy shared. Mathematics in particular, a big issue, right? We could not move forward from Pythagorean math without the Muslims in Baghdad, without their connections to the Indians, working on different mathematical concepts themselves. And all of this mathematical calculating gets us into abstract thinking that will eventually help with navigation, with measuring, with map making. The Chinese come up with a compass. Very important. The Chinese will come up with a rudder for a large ship, which we've said before, an ocean-going ship, which we'll need in order to navigate the seas. So mathematics, navigation, technology, philosophy, and then paper and printing we put towards the end here, because paper becomes a great source of record keeping. We're not using clay tablets. We're not using wax tablets. We're not using stone so much. We have paper. It's lightweight. It's portable. It can be reused. You can erase, if you will. Maybe you have to scrape away old writing on paper, but you can reuse it, and it becomes very important. When you add to that the printing press, which develops first in China and then in Europe in the 1400s, not only can you use paper and printing to record knowledge, you can use it to share it in an extraordinary fashion.